The integration by parts worksheet, question number 17, it gives us an integral x cubed over square root 4 plus x squared. And it tells us to use dv as x over 4 plus square root of 4 plus x squared. Now, first of all, we need to check to make sure that we can't use substitution. So in this case here, if we differentiated x cubed, we get x squared. However, the x squared is in the denominator and in its square root. If it was the other way around, we could use substitution, but in this case, we can't. So we can set it up this way. We need to, first of all, solve our parts. So our dv is x over square root 4 plus x squared here in red, and u is x squared. Our du is easy to do. Our du is going to be 2x dx. The v, we have to use substitution to solve for v. Okay, so I've set it up over here to the right. We're going to use substitution. So in this case here, since the numerator is 1 degree smaller than the denominator, we can use substitution. So we're going to let u equal the inside function 4 plus x squared, and that makes our du equal to 2x dx. So we're going to replace our x dx in this by du over 2. Okay, so we're going to integrate this expression. Okay, we're going to integrate both sides of this. We're going to end up with v equals, and we need our dx on this side. But when we do that, we're going to replace the x dx with our d over 2. We're going to replace the 4 plus x squared with our u function. Okay, so we end up with the integral of the square root of u in the denominator, and then the x dx is going to be replaced by du, and that's going to have a 1/2 associated with that, which we're going to put that out there. So integrating v, we're going to increase the power of negative 1/2 to positive 1/2. Okay, so we end up with square root u. Okay, we're going to divide by 1/2, so we get 2, and we had our original 1/2 our 1/2 coefficient there, and that's going to give us our v. Okay, so simplifying v, we get v is equal to, the 2's cancel out, and then I end up with v is equal to 4 plus x squared. Okay, so then I've solved for my v, so I can use that in my parts now. So in my parts, my v is square root 4 plus x squared. So then I'm gonna, since I've used the substitution to solve for my parts, but now I have the parts to apply integration by parts formula. So I'm gonna apply my integration by parts. So I'm gonna end up with u times v, which is 4 plus x squared, okay, and then minus the integral of v du. Okay, so I'm going to then use my v du, so it's going to be v and then I'm going to put my du in here, and I'm just going to leave it as 2x dx. So 2x times dx. Okay, so there's my v du. So then to integrate this part, this is an integral that we can do, and we're going to use, again, substitution to do this. So I'm going to let my u, my inside function u, be 4 plus x squared. That will let my outside derivative, or outside the derivative account for the outside 2x dx. So again, let u, this is substitution again, u is equal to 4 plus x squared My du works out to be 2x times dx. Okay, there's my 2x dx I'm going to use. So then I have a nice substitution that I can work out here. So my integral then is going to look like this: x squared square root 4 plus x squared minus, and when I do my substitution, I'm going to end up with square root of u, and then a 2x dx I'm going to replace with a du. So this is an integral that I can now work out. This works out to be x squared square root 4 plus x squared minus, and this becomes u to the power of 3 over 2. Okay, I increase the power of 1/2 by 1, and then divide by 3 over 2, so I get 2 over 3, and then I have my plus c. I'm going to substitute back, so I end up with minus 2, and I'm going to write this as x plus, so 4 plus x squared is my u value, 3 over 2 plus c, and that's all over 3. Okay, so there's my answer. I'm going to simplify this so it looks a little bit nicer. I have a common factor of square root of 4 plus x squared, so I'm going to factor that out. Okay, when I factor that out, I'm left with x squared minus 2, and then taking the square root out, I'm left with just 4 plus x squared. So I took the half power out, I'm left with 1 whole power, and that's all going to be over 3 plus c. And what I'll do is I'll get a common denominator in this step, so I'm going to times 3, divide 3, and then I'm going to simplify this expression. So I end up with square root 4 plus x squared, and then in the brackets here I'm going to get 3x squared minus 2x squared. That's going to be 1x squared, and we get 2 times 4 is 8, so minus 8. That's all over 3 plus c. Factor the 1/3 out. I end up with 1/3 square root 4 plus x squared and times x squared minus 8 plus c. Okay, so there's my antiderivative. I'm using integration by parts, but to generate one of my parts, I needed to use substitution. Once I generated my parts and put it into the formula, I generated another integral that needed substitution again. So I solved that by substitution, and then I cleaned this all up by factoring some common terms out and combining like terms. Now we can check to see if this actually works. We can check by differentiation. So when I differentiate this, so this would be my check. Hopefully I don't run out of room here. My check is going to be using my derivative. So I'm going to use the product rule here since I have a product of two functions. So it becomes 1 over 2 square root 4 plus x squared. Chain rule is going to times by 2x, and then times by x squared minus 8, plus, I'm going to end up with square root 4 plus x squared, and then the derivative is 2x. Okay, so then I'll get a common denominator here and cancel out a few terms. So I'm going to cancel these 2's out. So I'm going to end up with 1/3, and this is going to be x cubed minus 8x, and then that's all over square root 4 plus x squared. I'm going to multiply top and bottom here by 4 plus x squared, so I end up with 4 plus x squared times 2x all over the common denominator of root 4 plus x squared. So I multiply top and bottom by the root. That gets rid of the root in the numerator, and then now I can combine some like terms. So I'm going to end up with 2x cubed plus 1x cubed, that's 3x cubed. I'm going to end up with plus 4x and a plus 8x and a minus 8x. Those 8x's cancel. So I'm just left with x cubed. Okay, and then we can see that the 3's cancel out, and I end up with the derivative, or the derivative function that I started with, which was x cubed over 4 plus x squared. So there it is. There's my check. It gives me the original expression that I started with way up here.